Hello everyone, welcome to another episode of UK Women SA Industry Tech Talks. In today's session, I'm going to talk about a use case related to one of our print media customer where we created an automated press article generation using GenAI. I'm Radhika Jakkula. I'm a big data prototyping architect at AWS. I'm part of prototyping and cloud engineering team, also called as PACE. At PACE team, we help customers build prototypes for their innovative ideas. We prove to customers that their technical aspirations, cloud transformation, and business goals can be achieved with AWS as their technology partner. As part of my role, I help customers build prototypes along with them using AWS Analytics Services, purpose-built databases, and big data frameworks. What we'll cover today? We'll cover customer use case and challenge, goals and expectations, our roadmap to the solution, how we solve the problem, finally, some examples as outcome and recommendations. One of our Swiss-based print media customer who has a global presence is major player in media industry. They have been shaping the way people consume news and entertainment across the globe. This customer is faced with a challenge to provide content in different formats that is suitable to different audience. For example, a news related to current affairs, entertainment, or sports are of interest to general audience, whereas a news related to trades or stocks are of interest to specific audience and should include more details on numbers and graphs. Typically, in the news industry, the news articles are provided by news agencies, which is then rewritten manually. That includes proofreading and adapting to company's wording. This process includes a lot of manual work and is often slow. To streamline this process and support the journalistic work, the customer wanted to automate the process of rewriting using GenAI. They reached out to prototyping team to support this innovative approach and provide architectural guidance and technical knowledge on GenAI. The goal is to build an assistant for editors that processes and generates content in different styles. The ultimate goal is to accelerate the publication process with less human effort needed. As you can see on the right, the editor should be able to choose one of these styles. With error correction option, the article should be rewritten with any of the spelling and grammar corrections. With informal option, the article should be generated with creative wordings. With formal option, the article should be generated with formal wordings. With formal with context option, the article should be generated with formal wordings but additional information taken from the previous latest relevant articles. There are many ways to customize a foundation model. Typically, the life cycle starts with a simple prompt engineering, then RAG, and then fine-tuning, and as a final step, if none of the approaches prove to solve the problem, we go with pre-training a model. Also, as you see, as we move towards the right, the cost of implementation and the complexity increases, whereas as you move towards the top, the accuracy increases. We have to find a sweet spot where we can achieve results with good quality, performance, and with considerable costs. Here are the models we experimented with during our prototype. Some of these foundation models like Llama, Jurassic, Claude are available on Bedrock and hence could interact with them directly through Bedrock endpoints. For others, we use SageMaker to customize the models to interact with them. So now let's take a look at the key steps that we took and the decisions we made at each stage. We started with simple prompt engineering on each of the models. Most of the models were disregarded due to limitations particularly around German language despite tuning the prompts. Some models proved to have shown good results in terms of spelling and grammar correction but struggled to rewrite the articles as formal and informal styles. Claude demonstrated good results in spelling, grammar correction, and also demonstrated to create better articles in formal and informal style. We then explored implementing RAG to store sample articles with customer-specific style and providing this along with prompt. This demonstrated good results in some of the cases but not others. For example, Articles related to specific recent events like elections or sports, when provided with context, improve the quality of rewritten articles, whereas general news like crimes, accidents reduce the article quantity. So, this approach should be used carefully and only for relevant articles. Attempts at parameter efficient fine tuning using techniques like QLoRa were effective for exploring different approaches, but ultimately resulted in poor performance. The LLMs introduced errors, hallucinations, as well as grammatically poor sentences. Finally, RLHF is a process of learning from human feedback to optimize the models to self-learn. Due to lack of data in prototype, we were unable to implement this technique. However, the ability to rank the outputs have been provided to enable the customer to utilize this data for improvements. Now let's look at the following slides on how this can be implemented. This is a simple UI that has been designed. User can copy paste original article to be rewritten and will have 4 options to choose from. Once the generate button is pressed, the improved article is generated on the right side. The user doesn't have to have any knowledge on GenAI or LLMs. All the automation happens under the hood. As you can see, there is also an option for the user to rate this article. This accumulated data will help in implementing RLHF method as discussed in previous slide. In the following slides, we will go through the high-level architecture to see what are the various steps and service involved in accomplishing this process. The first step is to load the articles into S3 bucket on a periodic basis. Once the file becomes available in S3 bucket, the article loader lambda is triggered. This in turn invokes Bedrock to generate embeddings, insert the embeddings into vector database while retrieving the database credentials from Secret Manager. In this case, we are using Aurora PostgreSQL as vector database. In this step, the articles are pre-processed to format the original article. This includes adding 4 components to the article: super title, main title, lead, and main text. The processed articles are stored back into S3. Then the user can select one of the 4 options to generate the article. When generate button is pressed, the article generator lambda is triggered with relevant parameters to produce the improved article. The article generator lambda makes a call to LLM to generate embeddings for the original article, and upon receiving them, fetches the closest match from the Aurora database. The closest match is fetched based on recency and proximity. Relevant articles are retrieved from S3 based on the context. The lambda then consolidates user selected options, the context, and the original article to form a prompt. This is then submitted to Bedrock LLM to generate a new article. Once the lambda receives the response, the generated article window is refreshed with an improved article. Users can then decide whether they are satisfied with the result or wish to explore different modes. Now let's look at some of the examples of how articles are rewritten for each selected options. These examples have been translated from German to English for readability. As you can see, on the left is the original article and on the right is the rewritten article. First thing to notice is that the rewritten article is formatted into 4 sections as expected, including super title, main title, lead, and main text. This article is a generic news about an accident that has happened. In this example, the user has selected an option to correct errors. As you can see on the right side, the heading has been formatted as headline and the text has been translated from caps to camel case. Additionally, the text guidance in the original article is incomplete information and has been translated to a meaningful title. Rest of the article remains the same and only the corrections have been done. In this example, the user has selected the informal option. As you can see on the right side, the LLM has used creative phrases for super title like shocking accident. It also used catchy phrases like driver flees, terrible accident, driver overlooked the child. It also added a few dramatic phases, like the driver fled the scene from the accident without any further attention to the victim. Also, the original article does not indicate injuries to the child, and the rewritten article portrays that the child required medical care after the accident. It also added emotional messages like the accident is shocking and the driver's recklessness must have consequences. As you see, this option should be used carefully when the editors want to publish any articles with such creative writing. Now let's see what happens when a formal option is selected. As you can see, the same article has been rewritten in a very formal style. The wordings like child was taken to hospital with unknown injuries indicate that no new additional information is added, and the overall wording is very formal with no emotional or dramatic wordings. Finally, this is the example where an option of formal with context is selected. As explained earlier, in this example, the article is rewritten with additional information taken from previous latest relevant articles. Since this is generic news about accident, there could be several other previous articles related to accidents, and the LLM has picked up wordings from them. The phrases like the boy was thrown several meters through the air is clearly not in the original article. Also, it has appended additional information about police looking for the driver. Hence, this option should be chosen very carefully. It is not appropriate in such generic news articles, but could be helpful in articles like elections or trades, where details from previous latest articles could be relevant to add additional informations like statistics or trends. In summary, the majority of top performing articles of breaking news are published quickly with minimal rewriting. However, there is no one particular model or method that achieves the same outcome for all types of articles. Here are some of the recommendations based on the prototype tested. All the outputs that were generated were validated by a proofreader. Although the editor assistant was able to rewrite the articles quickly and efficiently, we recommend to have a proofreader in the loop to maintain control. The other recommendation is to implement reinforcement learning from human feedback, RLHF, which uses human feedback to optimize ML models to self-learn more efficiently. This involves generating customer-specific writing style using ranking system output for different style options for articles. This method may take some time but potentially generate better custom models with better and more consistent style. Here are some of the resources that you can refer to learn more about Bedrock and implementing RAG patterns. We have now reached the end of the session. I hope you enjoyed the content and are ready to explore our Bedrock and GenAI resources. Thank you very much.